developers, have you ever wondered why your search suggestions don't fire with every single keystroke? Or how websites handle rapid button clicks without crashing? Today, I'm going to show you something that will blow your mind. I've built this interactive visual demonstration that shows exactly how debouncing and throttling work in real time. And trust me, once you see this in action, these concepts will never confuse you again. Look at this beautiful interface we have here. We've got our input field, 3 event tracking sections, a code console that highlights in real time, and even a flowchart that animates as we type. This isn't just theory. This is visual learning at its finest. Watch this magic happen. See how the raw events are firing like crazy, but the debounced and throttled events behave completely differently? Stick around, because I'm going to break down every single detail of what's happening behind the scenes. Section 1. Interface Overview. Alright, let's start by understanding our visual playground. At the top, we have our input field. This is where all the magic begins. Below that, we have 3 columns. Raw events on the left, every single keystroke. Debounced events in the middle, the patient ones. Throttled events on the right, the controlled ones. Now before we dive in, drop a comment below. Have you ever used debouncing or throttling in your projects? I'd love to hear your experiences. Section 2. The Visual Code Console. On the right side, we have this beautiful code console. This isn't just static code. Watch what happens when I type. See that golden highlight? That's showing us exactly which line of code is executing in real time. This is like having X-ray vision into your program's execution. The debounce function is on lines 1 to 7, and throttle is on lines 8 to 16. As we type, you'll see these lines light up, showing us the exact flow of execution. Section 3. Raw Events. The Uncontrolled Chaos. Let's start with raw events. Watch this left column as I type quickly. Every single keystroke creates a blue event that instantly turns green. This represents the natural behavior. No control, no delays, just pure chaos. In a real application, this could mean hundreds of API calls or expensive operations running constantly. Notice how the flowchart highlights raw execute every time? That's showing us the immediate execution path. Section 4. Debouncing. Now, let's focus on the middle column, debounced events. Watch carefully. When I type slowly, the debounced events appear after a 1-second delay. But here's where it gets interesting. When I type quickly, watch what happens. The yellow active events keep appearing, but they never turn green. They're being canceled and reset with each new keystroke. See line 4 highlighting? That's the clear timeout function canceling the previous timer. And line 5 is setting a new timer. This is the heart of debouncing. Imagine you're implementing search suggestions. You don't want to search for H, then he, then hell, then hello. You want to wait until the user finishes typing. That's debouncing. Section 5. Throttling, the controlled flow. Finally, let's look at throttling. This is completely different from debouncing, and our visual demo makes it crystal clear. Watch as I type continuously. See how the throttled events are appearing at regular intervals? They're not waiting for me to stop. They're executing at most once every 500 milliseconds. The algorithm explanation updates to show us throttle limits actions to once every 0.5 seconds, even if you keep typing. This is perfect for things like scroll handlers or resize events. Common mistakes most developers do. Mistake 1. Confusing debounce with throttle. Here's the biggest mistake I see developers make, using debounce when they need throttle or vice versa. If I need to track scroll position continuously, watch what happens with debounce. Debounce only fires when I stop. That's useless for scroll tracking. But throttle? It gives me regular updates throughout the interaction. Mistake 2. Wrong delay values. Another common issue, choosing the wrong delay values. Our demo uses 1000 milliseconds for debounce and 500 milliseconds for throttle. But these aren't magic numbers. What delay values have you used in your projects? Share in the comments. I bet we'll see some interesting variations. And there you have it. We've just witnessed debouncing and throttling come to life through visual demonstration. You've seen raw events firing with every interaction, debouncing waiting patiently for the user to finish, throttling maintaining steady, controlled execution, real-time code highlighting showing exactly what's executing, animated flowcharts making decision trees visual. Key takeaways. Remember these key points. Debounce when you want to wait for the user to finish. Search, validation. Throttle when you want regular controlled updates. Scroll, resize. The visual feedback in our demo isn't just pretty. It's a learning tool. Before you go, I need your help. Like this video if the visual demonstration helped you understand these concepts better. Subscribe and hit that notification bell. I'm creating more visual programming demos like this. Comment below with your biggest takeaway or a question about implementation. Share this video with any developer who's ever been confused by debouncing and throttling. And here's a challenge for the community. Can you think of other programming concepts that would benefit from visual demonstrations like this? Drop your suggestions below, and I might just build the next demo based on your ideas. The code for this demo will be in the description, so you can experiment with it yourself. Try changing the delay values, adding new event types, or even building your own visualizations. Programming doesn't have to be abstract and confusing. With the right visualizations, even the most complex concepts become clear and intuitive. That's what this channel is all about, making code visual, interactive, and fun to learn. Thanks for watching, and I'll see you in the next visual coding adventure.